set of notes. Let's see which one. This one. So this is week 7 of class, which means next week is week 8, the very last week of class. We're not going to be doing any new material next week. We're just going to be reviewing for the final exam. Speaking of the final exam, that is the big thing that you guys have going on next week. So on Monday, May 24th, early in the morning, the final exam for IPC will be posted in the Google Classroom. And similar to the midterm that you guys took a couple weeks ago, the final exam will be over 3 days. So once it gets posted, you'll have all day on Monday, all day on Tuesday, and all day on Wednesday to work on and turn in the exam. Hey, Guillermo, good to see you. And so the exam is set up very similarly to the midterm. You can take a Google Doc version that is very similar to seeing the exam paper in front of you, or you can take the Google Form version that a lot of you guys have been doing for your homework assignments this term. Just like the midterm, the Google Form is split up into different sections, with the first couple sections are all on some of the new stuff that we've been talking about. So the units and the density and the conversions and the laws of motion stuff will be the first couple sections. And then the last section is a review section that covers all of the term that we have talked about. So going all the way back to like atoms and neutrons and protons, talking about solid versus liquid, melting versus freezing, all sorts of that good stuff. It could all be covered on the final exam in that last section. So that's why on Tuesday, we're going to be doing a big review of everything that we've talked about in class so far to kind of refresh and remind everybody about what are some of the big ideas for some of the major topics that we have talked about. So you have 3 days to work on and turn in the exam starting on Monday of next week, but it is very, very, very important that you get it turned in by the end of the day on Wednesday. And that is because grades from us teacher to the school are due on the middle of the day on Thursday, noon at Thursday, which means that between midnight on Wednesday when the exams are due and the noon on Thursday, I have those hours to grade everybody's exams, post that onto Skyward, and submit those grades into the school. So if you don't get it turned in by the end of the day on Wednesday, then I probably won't see it, and you probably won't get a grade, and it'll go as missing or a 0 in your grade book. And you really don't want that to happen. So make sure you get that exam finished and turned in by the end of the day on Wednesday, May 26th. So if you remember nothing else from class tonight, remember May 26th, get everything turned in. Final exam, turn it in. Also, any missing or late assignments that you're still working on and haven't gotten turned in yet, those you'll want to get turned in as well. Just getting a couple of those missing assignments turned in and graded can be super helpful for your overall class grade. And so you can check yourself on the Google Classroom or on Skyward if you're missing any assignments, or feel free to reach out to me and ask me to check on it like Yvonne has done. Yvonne's emailed me and asked about, hey, is there anything I'm missing? Is there anything I can turn in to help my grade? And I looked through her old stuff, found some stuff that she could turn in that was missing or that was resubmitted, and she was able to do that and bump her grade up a pretty good amount. So that goes for everybody. If you want to check and make sure that you're not missing anything, always feel free to email me or text me. But again, all of that work and the final exam are going to be due Wednesday, May 26th. So at the end of the day on Wednesday is when all IPC work has to be turned in to me. If you turn it in on Thursday, I'm not going to look at it. I'm not going to grade it, and it'll go down as a 0 in the grade book. And the exam is worth, I think, like 28 or 30 points. And that's a pretty significant chunk of your overall grade. So that's what's coming up next week. All of the other daily assignments are super simple questions about, like, what do you want to review? What did you find really hard? What did you think was really interesting or really easy to learn about this term? Stuff like that. So you can answer pretty quick to get your attendance, but mostly focus on working on that final exam and getting it turned in. All right, so here we are at the end at week 7. Okay, Robert, good to know. Thanks for the heads up. So here we are at the end of week 7. We talked yesterday about the first 2 laws of motion. So let me pull those up again really quick here. So on Tuesday, we talked about the first law of motion. Objects will stay at rest or in motion until some outside force or unbalanced force acts on them. And the second law of motion, force equals mass times acceleration. There's a relationship between mass of something, how quickly it accelerates, and the force that was used. So today, we're going to talk for a little bit about the third law of motion, which is called the action-reaction law. For every action, there's an equal and opposite reaction. So I'll describe it to you first kind of in words to say what it is exactly, but then we'll go through a whole bunch of examples that I think do a really good job of illustrating exactly how the third law works. So the third law of motion, the action and reaction law, in big, complex science terms, says when one object exerts a force on a second object, the second one exerts a force on the first that is equal in magnitude and opposite in direction. So for a lot of that, you're probably like, I kind of sort of know what some of those words mean, but put them all together and I have no idea what's going on there. Essentially what it's saying is that if you push on something, it's going to push on you back. If you exert force against some object or some matter, it's going to exert an equal force back the opposite direction onto you or onto whatever object put the force in. So again, it's kind of really hard to understand just in terms of words and explanations. So let me hit you with some examples that I think illustrate this beautifully. So when a rocket ship is blasting off and going up to space, 3, 2, 1, lift off. At the bottom, you see it gets light up because all of this hot gas and hot combustion that's going on inside of the boosters right here is all shooting downwards out of the boosters, out of the rocket ship. So all of that hot gas, all of that fire is shooting down. As that shoots down, the third law says that if we have one force going down, we have to have an equal opposite force going up. So while there's a big force shooting all of that gas and fire down out the bottom of the rocket, there then is an equal force that pushes the rocket up off the ground and into space. So as the gases that are burned inside these boosters move downward out of the rocket, it pushes the rocket up. Action, reaction. Hot gas coming out really fast pushes the rocket up really fast. So as you have all of that exhaust, all of that thrust from the rocket engine shooting out the back of the engine, the back of the rocket itself, the ship that the astronauts are in, gets pushed forward. It gets pushed this way. So equal and opposite reaction. Action going this way, pushing backward. Opposite reaction pushes the opposite direction, pushes forward. So when it said that the force that is initially exerted has an equal force in the opposite direction, This is what it's talking about when we're talking about forces in opposite directions. If you have a force being exerted one way, there's going to be an equal force that's exerted back the other way. Hot gas comes out to the right, rocket gets pushed forward to the left. Another example that I think really helps illustrate this is birds. Birds fly through the air by flapping their wings, right? We've all ran around the front yard flapping our wings trying to fly when we were little. No worries, Tammy. Thanks for being here. So when a bird is flapping its wings, there are two things that are happening. The bird is pushing down on the air in the sky. So as we've talked about, air is a gas. Gas has mass and density. So if you've ever just taken your hand and move it really fast in front of you, you can feel the air that it's moving through, right? Birds do this, but on a much stronger scale. So they're pushing that air down hard with their wings. So that's the first thing going on. The second thing is that the third law says that the air is pushing back on the bird. So the wing of the bird pushes down on the air, and the air pushes back up on the bird. And this is what allows them to fly. You can see in this GIF right here, as the bird flaps its wings down, the bird itself is lifted up. It's generating lift by pushing on the air. So the wings and all those feathers are constantly pushing down on the air. And as they do that, they're pushing the whole bird up into the sky. The air pushes back on the bird and pushes it up into the sky. Action, reaction, equal and opposite force. The air pushes down, or the bird pushes the air down with a certain amount of force, and the air pushes back up on the bird with that same amount of force. So the forces are opposite because the bird pushes the air down, the air pushes the bird back up, always in the opposite direction. Gas comes out of the rocket ship down, the rocket ship goes up. And the size of the force on the air, so this force that the bird is putting on the air, is equal to the force from the air on the bird. So we have equal and opposite reactions. So whatever force the bird puts into the air pushes back on the bird with that same amount of force, just in the opposite direction. So here's one of my favorite examples because I can actually show you guys how this works. So imagine that you're standing on roller skates or a skateboard, or in this case, you're a science teacher who's sitting on a chair with wheels on it. You push against a wall, or in my case, I'm going to push against this table that is here in front of me. So my arms, my strength, my force is going to be pushing towards you guys, right? I'm up here and I'm going to push towards the table. So here we go. Got my arms on the table. I'm going to exert a force towards you guys. And as I exert a force towards you guys, I get pushed back. I put a force on the table put that same force back on me. And because the table is sitting on strong, sturdy legs, and I am sitting on wheels that roll very easily across this hard floor, I'm able to slide. Same exact thing would happen if you're on a skateboard or if you're on roller skates. You push against a table or a wall, and you go backwards because the wall is pushing back on you. You put a certain amount of force into the wall, and the wall exerts an equal amount of force in the opposite direction, straight back onto you. So that's why even though I'm putting force towards you guys into the table, I move backwards, away from the table. It's all because of these action-reaction forces in the third law. It's all because when you push against something, it's going to push back. This is why it hurts a lot when your toe hits a rock. Your toe is probably moving forward with some amount of speed, and then it hit that rock. It exerted a force on that rock. The problem, if it was a big rock or like a brick or something, is that that rock is going to exert a force right back on your toe. And that's what makes you stub your toe and go, ow, god dang, that hurt. Because while your foot and toe exerted a force on the rock exerted a force right back against your toe. Equal and opposite action, equal and opposite forces. Balloons are very similar to rocket ships in terms of when air and gas shoots out, they go up. So this is the reason why after you blow up a balloon, you have to hold on to that little skinny part at the bottom, right? The neck. You can let the air out a little bit at a time, and it makes kind of like a funny noise. But if you let that thing go, the balloon's going to go and zoom all around, right? Because it's constantly having air pushed out the bottom of it. And so it's constantly being forced upward or being forced forward or whatever way that it happens to be facing at the time. Whichever way the air is rushing downward out of the balloon is going to be forced upward in the exact opposite direction that the air is coming out. Swimming for us is actually very similar to flying for a bird. We're just doing it in water instead of on air. But when you're in the water and you're swimming and you're going and you're going, you reach forward and then put your arm in the water and pull it back. Put your arm in the water and pull it back. So you are pushing the water backwards, right? You're pushing against the water as you're swimming. Because of that, the third law says, okay, if you push the water backwards, the water is going to push you forwards. So this is what allows you to swim along the surface of the water. You are pushing the water this way, you're constantly pushing water behind you. And as you do that, the water is constantly pushing you forward, constantly pushing you in the direction that you're heading. This guy over here is probably about to be in for a bad time because he thought that he was close enough to the shore where he could just step off the boat and he'd be fine. But what he's going to find is that the third law says, oh, you're going to put some force down into your foot and step forward off the boat. Well, when you do that, no worries, Naftali, good to see you. When you do that, the boat is going to shoot backwards. Because while you push off of the boat to go forwards and hopefully step onto shore, the boat is going to be pushed backwards and right out from under your legs. So this guy is probably about to belly flop right into this nice little puddle right here. Action and reaction. You push on something, it is going to push back on you. The boat is pushing on your foot to allow you to move forward. You are pushing back on the boat, which is going to cause it to scoot backwards across the water. So this is what the third law of motion is all about. Anything that exerts a force on a second object is going to have a force exerted back on you. Whether that object is water or air or boats or skateboards or rolly chairs or tables. You push on something, it's going to push back on you with the same exact amount of force and the same amount or the exact opposite direction of the initial push. Again, notice both these arrows going in opposite directions from each other. So equal in magnitude, which is just a fancy way of saying the same amount in science terms, but opposite direction, going opposite ways. If you're playing baseball and you swing the bat and you hit the ball pushes your bat backwards to the left in this case, but your bat pushes the ball forwards. So that contact causes the ball to shoot off in the other direction because there's a lot of force that got impacted here. The bat will move to the left a little bit because somebody is hopefully holding on to it strongly. And so we have this action-reaction force. The ball comes in and exerts a force on the bat. The bat exerts a force right back on the ball, maybe even hitting it out of the park for a home run. Action-reaction forces. Opposite forces that are in the same magnitude, the same amount. Again, no matter what two objects you have, even if you have two random objects, like a cup or an apple or a Sprite can and whatever this protein drink used to be, I don't know, it's not mine. Whenever they come together and exert a force on each other, there will always be another force in the opposite direction. So no matter how much force this Sprite can comes in and hits this plastic bottle with, the plastic bottle is going to exert the same amount of force back on the Sprite can. Equal amount of force, just in opposite directions from each other. That is what our third law of Newton's motion is all about. Anybody have any third law questions so far? Anything that still is kind of weird or that you're not really confused about or understanding with our third law of motion here?
No, sir.
All right. So hopefully then, whoops, I was going the wrong thing here. That initial slide makes a little bit more sense to you now. When one object, like say a science teacher, exerts a force on a second object, like say a table in his classroom, the second object, the table, exerts a force on the first, the science teacher, that is equal in magnitude. Again, just a fancy way of saying the same amount of force. So equal in magnitude and opposite in direction. So same amount of force, but exactly opposite from each other. Whichever way that the first force is going, the second force is going to be in the exact opposite direction. So that is our third law of motion. So if we go back and look at all of the laws all together, these are the three basic laws of motion that, as far as we have studied, apply to everything in the universe. Every molecule, every gas, every solid and liquid, from water and steam and air on Earth to planets and suns and other solar system, they all obey these three basic laws of motion. Number one, an object will stay at rest or stay in motion at the same velocity unless acted upon by an outside or unbalanced force. So in order to get something to start moving, or to get it to stop moving, or to get it to speed up or slow down, you have to have some sort of different amount of force come along and change things. It can't just happen on its own for no reason. There has to be a force. The second law says that there's a relationship between force, acceleration, and mass. Force is equal to mass times acceleration. The more mass that you add on to something, the more force that you're going to need to push it at the same speed. The quicker that you want something to accelerate, the more force you're going to have to put in order to get it to go faster. So there's a direct relationship between force and mass and between force and acceleration. If one of these two things go up, that means that the amount of force that was applied is going to go up as well. And then finally, our third law that we were just talking about right now, for every action, there is an equal and opposite reaction. For every force that's exerted on any sort of object, that object will exert a force in the same magnitude, the same amount of force, but in an opposite direction to the initial force. If I push on this table is going to push back on me with that same amount of force. So all three laws of motion describe sort of the most basic rules behind how things move and how things are able to move in the universe. All right. Does anybody have any more questions? Anything about any of these laws, the first law, second law, or third law, that you still have questions on, you're still confused about, you still want some help with?
No, sir.
No.
All right. Cool. So I tried to make sure that it would be a little bit more of a short and sweet class today, seeing how it is our very final Thursday IPC class that we're going to have. So your homework, your daily assignment for today, pretty straightforward. I want you to describe a situation that you think is a good example of the third law of motion. This could be something you've done or just kind of like an everyday generic example, like some of the ones that I gave to you guys about the birds flying or standing on a skateboard and pushing on something. So describe a situation that kind of really nicely illustrates the third law of motion. This idea of if you put force on something, it's going to put force back on you. So again, it could be a generic example. It could be something that you've seen recently. It could be something that has happened in your life in the past. Whatever it is, I don't want you to tell me what the third law of motion is. I want you to give me an example of something that kind of shows the third law of motion in action. So that is your only assignment to finish off week 7 here. And then again, next week, week 8, the big thing is going to be working on that final exam. So remember, get it turned in by Wednesday. We'll talk about it a little bit on Tuesday, and I'll go over a review of some of the major concepts from all of the parts of class that we have talked about so far. But again, please make sure that you get that final turned in by the end of the day on Wednesday. If not, then it might go down as a 0 in your grade, and that would be very much no bueno. So that's all you really have to work on next week. All these daily assignments are just simple questions that you should be able to answer in like 1 sentence in a couple minutes. So besides meeting up for class on Tuesday, your major goal next week is to finish up and turn in the exam, and also check out your Google Classroom, check out your Skyward, and let me know if there are any missing assignments or any late work that you want to know about or that you want to make sure get turned in by the end of the day on Wednesday. All right. Does anybody have any final questions? No worries, Star. Thanks for hopping in with us here. I appreciate you making the effort. Does anybody have any final questions on any of our laws of motion or anything coming up here at the end of the school year?
No, sir.